Hey everyone, have you ever noticed that sometimes your 5G connection is not much faster than your old 4G? Let's break down why that happens. It is generally about your location. So let's dive in. Five G consists of three frequency ranges: high band, mid-band, and low band. Now I'm going to use this diagram here to explain to you how the 5G networks actually work. Now here I have the high band, the mid-band, and the low band. I'm going to start with the high band first, and then we'll go on to the mid-band and the low band afterwards. Now the high band has a frequency range from 24 gigahertz to 40 gigahertz with a maximum data rate of 10 gigabits per second. Now these high frequencies are not capable of being transmitted very far. The distance is 500 meters, which is very short, so it can't be transmitted to a large area, just a very small area of 500 meters. And the reason for this is because these are millimeter waves, very short waves, and they're not capable of going through walls or even trees or any obstacle in the way at all. These waves will be reflected off these obstacles. They don't go through. So you actually require a direct line of sight. Like here we have a direct line of sight with the antenna, so you will be able to receive a nice strong signal. If there's a building in the way or anything in the way, you will not get your signal using these frequencies of 24 gigahertz to 40 gigahertz. Now this area that's in is called a cell. Basically this is a 500 meter cell, a very small cell. Whoever is broadcasting to has to be within 500 meters of the antenna, which is very close. So this type of service is perfect for places like airport terminals or bus terminals, arenas, anywhere where you have a large group of people all in one location, and they all can access the internet from that location. So once you're outside of this 500 meter limit, you won't be able to receive your cell signal. You're into a different cell, which is the mid-band cell. This cell here goes from 1 gigahertz to 6 gigahertz with a speed of 100 to 900 megabits per second. You can pick up this range of frequencies anywhere between the 500 and the 2 kilometer range, but you could also pick it up here too, because you remember your signal is being sent from this antenna. So once you're in this area, you should be able to pick it up. That should, depending on if you're getting a good high band signal. Like if you are in this area and the signal is being blocked by a building or trees or anything like that, then your phone would pick the next best signal, which is the mid-band signal. So you could be in this area and still receive this signal. Of course it would drop. You wouldn't get the high data rate of 10 gigabits per second. You would actually just get between 100 and 900 megabits. And since you're so close to the antenna, you'll probably get something closer to the 900 megabit range in here. Now once you're in this area here, you will get a little bit lower speed than if you're closer to the antenna, but you'll get something, if you're close to this 500 meter line, you'll get something around 800 megabits per second. And as you go further down towards the 2 kilometer line here, this is where the cell ends, you will get something closer to the 100 megabits per second. So basically with these frequencies, the further you go away from the antenna, the weaker the signal gets, right? So the slower the phone would get. So this mid-band is between 1 gigahertz and 6 gigahertz, right? So you look at the difference, 24 gigahertz to 40 and just 1 to 6, much lower frequency. That's why the speed is so much lower, right? So this is usually used for the suburbs. Okay, like these frequencies can go through walls. The 1 gigahertz can go through walls pretty good, and no problem there. But as you get up to the 6 gigahertz, it's a little bit harder. You would experience a little bit more loss with the 6 gigahertz frequency versus the 1 gigahertz, but it would go through the walls just like the 1 gigahertz, but just a little bit more difficult, experiencing a bit more loss. But it works a lot better than the high frequencies, which can't go through the walls at all. So this mid-band is perfect for the suburbs. In the real world, this is what we use in the suburbs. This frequency, the mid-band frequency, from 1 gigahertz to 6 gigahertz. So after you pass the 2 kilometer range, these frequencies here cannot reach past 2 kilometers. So it's 2 kilometers from the antenna here. It cannot go past 2 kilometers. The signals get very weak. So at this point we get into the low band area, which is between 600 megahertz and 850 megahertz. This is the much lower frequency, and because it's so much lower, the speeds are between 50 and 250 megabits per second. The lower the frequency, the greater distance that frequency would travel. Like as we look back up here, the 24 to 40 gigahertz did not travel very far, just went to 500 meters. The 1 gigahertz to 6 gigahertz went 2 kilometers. And now the low frequency between 600 megahertz and 850 megahertz could go 10 kilometers. But the lower the frequency, the lower the speed as well. So all we got here is between 50 and 250 megabits per second. In here, you'll get something between 100 megabits per second right here at the 2 kilometer line. And right down here at the 10 kilometer line, that would drop to about 50 megabits per second. But if you go right back up here, and for whatever reason, you couldn't receive the 24 to 40 gigahertz frequency, or the mid-band frequency from 1 to 6, the next frequency that you would pick up would be this one. But you will get this frequency here of between 600 megahertz and 850 megahertz at something close to the 250 megabits per second in this area here. So once you're close to the antenna, 250 megabits is what you would pick up, right up here. But as you travel down this way, you'll find that the speed is starting to drop as you go further and further away from the antenna, until you get right down to the 10 kilometer line and your speed is just 50 megabits per second. So frequencies between 600 megahertz, 850 megahertz using these lower speeds would be found mainly in the rural areas. Now you'll hear some people may say that my 5G phone is not much faster than my 4G, and that can be quite true in a lot of cases, especially for people that live in rural areas. The highest 4G speed you will have is approximately 100 megabits per second. But if you should have a 4G and a 5G phone sitting together, receiving speeds from the same tower at the same frequency, the 5G will be faster, for the simple reason that the 5G has better modulation. It doesn't matter if you're using 4G or 5G, the speeds will always be slower because of distance. The further you are away from the antenna, the slower the speed is going to be, because you're going to have a lot of loss along the way. This is Trevor from Telecom Training. I really hope this video was helpful to you. And if you would like to see more videos like this one, please don't forget to like and subscribe.